with that, I want to introduce Bill Hollifield. He's been with us at PAS for 15 years. Before that, he was 30 years, almost 30 years in the industry. Couldn't get those last two, but as in the petrochemical industry, he has been on just about every committee from ISAE SP 18, ISAE SP 101, the HMI, API RP 1165, the EMUA Industry Review Group. He's co-author of the Alarm Management Handbook, the High Performance HMI Handbook. He has been a phenomenal consultant and advocate for alarm management and HPHMI principles. If you haven't read the book, I really highly recommend it. If you need a copy of the book, reach out to your salesperson. I'm sure they will be happy to help you out to getting a book. And with that, Bill Hollifield.
Thank you. Thank you all for being here. If you've been on any of my webinars, you know I'm going to pack a lot of information in a short period of time, which is good in these afternoon sessions. So this one, this presentation is a little different. This is not about the basic principles of high performance HMI. I've got some great white papers and things like that on that. This is about some particular practices that I see happening that are bugging me. All right, so the overall concept we're going to call camouflage. And how camouflage is relating to some HMI practices. So camouflage is basically about how not to be seen. And if you want a good, funny 3 minutes, go to YouTube and search for Monty Python, How Not to Be Seen. Okay, don't do it now, all right? But the basic way not to be seen is don't stand up, all right? So how does that relate to HMI? Well, let's look at some examples of camouflage, okay? And of course, they're easy to find. That one you might see a little bit in this higher contrast review. The first time I looked at that, I didn't really see this part. I just saw kind of the center part without that. So that's one example. You can see that what you're doing there is called pattern matching, one type of camouflage, as well as color matching. Here's another example, very scenic. There's what you're looking at. There's the thing that's camouflaged. Here's another couple of examples, both pattern matching, edge blurring. You see, the human eye is evolved. It's absolutely excellent, the eye-brain combination at edge detection, at seeing an edge. Because if you can see the edge of, this comes from our days as prey. Okay, if you can see an edge, that's how you defeat the camouflage. So edge detection is very important. It's a fundamental capability. Just a couple of more examples: things you see, things you can't see. Camouflage in nature. So humans have. There's a whole science of camouflage. The primary things that you're going to try to do to camouflage something, first of all, is pattern matching. So pattern matching is when you put the thing that you're trying to hide in a bunch of similar things. Okay, so here's all of this, but look here's pattern matching. Okay, but it blends right in. Color matching. Here, depending on your capability, you may or may not be able to read the words. In one case, color matching is a lighter red than the red background, or a darker. You may not even see that. Some of you may not even see this, right? And this is, when we talk about high-performance HMI, this is the absolute thing we want to avoid, the stupid red-green paradigm where a substantial fraction of our population can't even tell that apart, yet we use it for all kinds of things in something running or not running, or energized or not energized, or whatever. Now, we're going to advocate brightness coding, but again, that's a separate concept. But we're going to get rid of this stupid red-green paradigm. But color matching is important in camouflage. The other thing, the other thing is getting rid of edges. Look here, I left the edges on this part, and you can see how much more that stands out. I mean, it is visible, as these hardly stand out at all, or not visible, but there's no difference in the coloration. A thin 1 pixel edge on something can really make it stand out and be visible. Now, there's another kind of camouflage in the military, and this came out of submarine warfare and primarily in World War II. It's called Dazzle patterns. Now, you can't hide a ship on an ocean, all right? But in submarine warfare in World War II, the sub would come up to periscope depth. They'd put up the periscope. There were specific things they had to do. They had to know the range to the ship, the direction the ship was moving, and they couldn't do a periscope sighting. You're not staying up there for minutes because every ship had lookouts, and if they spot the thing, here come the depth charges. All right, so if you wanted to survive being a submariner, you would have the periscope up for maybe 3 or 4 seconds. So you're supposed to, there's tossing seas and there's fog and there's all this. So you're trying to figure out how big is the ship, how far away is it, what direction is it going, all in 3 or 4 seconds. So these kind of dazzle patterns, I mean, what direction is this ship going? All right, is it coming straight at you? No, this is the bow here. So that was a very effective form of camouflage in those old days where optical sightings were important in submarine warfare. So we're basically confusing the range, the speed, the movement direction, and the size by exaggerating and misdirection. When you combine all these, you get something very interesting. This is Lou Bolin. You can look him up on the web. This one is probably phenomenal. These are art pieces. Here are his shoes right here. Okay? So a combination of all kinds of stuff in that one. So how does this affect HMI? Now, this is obviously not an example of good HMI. This would be an example of camouflage, however, in the kind of the dazzle pattern. All right? We have almost everything in this example graphic is visually distracting. All right? Spot the alarm. Where's the alarm? Is this thing having the best day it's ever had, or is it about to explode? You know, how can you tell? Is it running well? Is it running poorly? This is just a typical bad example of HMI. Are the numbers important? They're teeny tiny. Is yellow important? Is red important? You know, who knows? Now, the problem that is coming out is a lot of is when practitioners and people that are creating graphics confuse something being visible where you can see it with the fact that it's visible being supposedly visually distracting. And so what we are seeing, I mean, we wrote the High Performance HMI Handbook and published it in 2009. And we were just absolutely astounded at the response, and people began kind of following those principles and developing HMIs. And then, of course, everybody jumps on the bandwagon. Everybody's an expert, and you see all kinds of crazy stuff going on now. And what I'm going to do in this presentation is call some of it out. So we don't want to be distracting, but we do want to be visible. All right? We don't want graphics that are an eye test. So I'm going to show you a disturbing trend that I am seeing a lot of, because I look at things on the web, and I mean, people, if you publish something on the web and you say this is a good HMI, then prepare. If it is, great, I'll support you, but if it's not, we're going to lob some things at you. So I want to start with what we think good looks like. This is an example of an overview display. It's for a power plant, and many of you have seen this examples before. The thing about it is things on it are visible. You can see them. We have trends at the top, the most important trends for running the power plant. We have status indications. Even the trends have indicators to the side here for the normal or desirable range of its color-coded trace. We have analog indicators. We put these in banks so your eye can easily flow across them. You know, and the light blue area represents normal, represents desirable. So my eye can scan across this and I can see everything's normal, low, an alarm condition. We make the alarm conditions stand out. We want the alarm conditions to be highly visible. This is low. This is, you see in these indicators, this is the normal range. This is where a high alarm is configured. This is where a low alarm is configured. This one doesn't have either a high or a low alarm. This one has a high and a high high. You notice how you can see the edge. this little 1 pixel line is very important. It's the edge, and you can tell when the pointer gets close to the edge. And so the alarm comes in, a separate redundantly coded alarm indicator appears, it brings your attention to it, and so forth. All right, so this is an example of using analog indications to provide context. You don't control from this screen, you control from what's called level 2. This is your overview. This is a how am I doing? This is what do I need to look at? There's good contrast. I can see everything on the screen. I don't have to squint. Everything, I can understand where I am in my various ranges. I am showing the numbers like I am supposed to. I have controllers and so forth. This is level 2. This is where you do your work. This is an exothermic reactor. Again, you get a little bit of a PNID flavor here. The thing to avoid is a PNID with a bunch of numbers on it. That's not a good graphic for attaining and maintaining situation awareness. So I have just enough of a PNID flavor so you can be oriented. But again, on my important indicators, I'll line them up so my eye can scan across them, all right? And I can detect what's good, what's bad, what's normal, what is an alarm. I make my alarms stand out. 3 alarms are in effect. I have embedded trends, okay? I have interlock indicators. This works on the principle of a faceplate. Anything I touch or click on, the faceplate appears for it in a reserved area. The faceplate doesn't appear on top of what I'm doing, and then the first thing the operator has to do is move it around. No, we force it to appear here. We have good navigation and so forth. One of the things you do in High Performance HMI is to take into account the fact that you have created a master alarm database. You have information about every alarm, so you give the operator the ability to call up that information, put it in a faceplate form. Every operator can understand every alarm. All right? These are just good principles. But again, notice how you can see everything. Nothing is hidden from you. Nothing is invisible. You're not squinting your eyes to see it. Level 3, this is where your PNID view lives. You don't have to sacrifice all those other things, but it's good to have a schematic drawing of what your process is like, what the numbers are, but you can still have analog indicators. You can still have trends. You can still have interlock tables of initiators and actions and so forth. All right? So we consider these to be good. They're a good contrast. Everything's visible. Alarm conditions stand out. The use of color is not exaggerated, but it's there. This is not totally devoid of color. So in even a PNID depiction, we want things, remember these 3 words, clear, clean, and crisp. What you're looking at here, the simple thing, everything is clear, clean, and crisp. You can make it all out. For the tank level, put a trend there, all right? So what is not clear, clean, and crisp? This is not clear, clean, and crisp. This is an eye test. This is what I'm seeing all over the web. People are confusing the idea that if something is visible, it's visually distracting. So they go so far into this low contrast realm that you have made it difficult for the operator to actually determine what's going on. Now, you may think I have exaggerated these. Okay, you may think, oh, Bill's, for effect, he's exaggerating those, how poor this contrast is. No, I've done sampling, okay, from actual graphics that people have out there, and I'm going to show you some of them, where this kind of really dumb thing is being passed off as, quote, high performance HMI. Well, it's not. You want things to be visible. All right, so let's take a look at these. This was in a magazine about a year ago. It was called a level 3. It's a very poor level 3. What they did was they took this PNID depiction. First of all, they didn't even clean it up to get rid of some of the crossing lines. There's plenty of crossing lines on here that are crossing for no reason whatsoever. 10 minutes, if you looked at this for 10 minutes, you could figure out how to get rid of almost all of them. They've scattered all across it tiny little analog indicators, all right? But there's no numbers. I'll get to that in a moment. Can you tell how close this is to this tick mark? Can you even see these tick marks? I mean, what is the point? So these things are dim. When they do no, that's not in this case. Lots of crossing lines. They have the wonderful idea that if everything's good, we don't even show the numbers. No. You always show the numbers. You want the operator to be building a proper mental model. So if something's in the normal range, you also want to show the number. I mean, if you went into your doctor's office and he looks at your blood pressure numbers, you kind of expect him to understand those numbers. So that's a stupid idea. We only show the numbers if it's abnormal. I have a pension. I can pretty much say what I want. All right.
Bill, we may need to remove you. We may need to remove you.
Okay. All right. So there's no trends, there's no condition indicators. You can't tell if the thing is running well or poorly. And even the analog indicators are just scattered around the screen. I mean, you're looking here, 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 and here, and plus you can barely see them. This is bad. So I call these blob graphics. Gray on gray blobs, unbounded. There is no thin 1 pixel line around this to help you in even seeing this shape. Putting that little line around it wouldn't make it visually distracting. It would make it visible, and there's a difference. All right, so we want to avoid that. We want to avoid tiny little fussy objects. Here's another example. One of the things you'll see a lot is somebody thinks it's a good idea to put yellow text on a gray background. That has almost zero contrast and is just a terrible thing to do. You can't hardly read those, and you notice this is almost full screen size. Okay, this has some other issues. The analogs are bar type rather than pointer type. There are really good reasons why why it's much better to use pointers than bars. I'm not going to go into that, but you can get our white paper or our book, and we'll tell you exactly why that is, and we can prove it. But there's all kinds of other things here. Lots of crossing lines, lots of jagged lines, just things that make no sense. Again, is it running well or poorly? How do you know? There's no trends, and so forth. So there's a lot of confusion here. People will even use yellow as the color of a line on a P&ID type drawing on a gray background. No. This one is rather interesting. It has a few halfway decent ideas shown on it, but it is so hard to read. Look at this here. Look at this tank. Look at this analog indicator. Can you make this out? All right. We're showing a temperature profile. They're showing it with a line here, but the contrast is so poor, and it makes a difference if this teensy-bincy tiny little thing is filled or not, and the fill is not much different than the non-fill. Here you've got, again, an analog indicator where the bar is a very light pastel green on gray. That's not a lot of contrast. What else do we have here? I call this an eye chart. Well, actually there are. It could be that some of these little indicate. Well, see, here's one of the problems when you use a bar in the middle is that you can't have a range without the bar overriding it. So that's why we say a pointer next to a thing that's showing the ranges that's one of the reasons why that's a superior method of depiction. We'll get back to that. So anyway, a lot of issues with this. At least it has a trend, although you can't read these numbers. They're so poor in contrast. There's one of these. I think that's the next one. All right, so if you were actually going to do this, they got this we published this in 2009. I mean, here's a temperature profile. You've paid all the money for these temperature indicators. Is this a good profile or, with just the numbers, is it a good profile or a bad profile? Well, if you show it this way, too hot at the bottom, too cold at the top, here's my normal ranges, you can at least read it. Okay? So, but here you can't even read this thing that they went to all this trouble building. So that's pretty lousy. This is an example of one where we're using these teeny tiny, very fussy, low contrast elements in these analog indicators. I mean, there's about 3 pixels used to put this little uptick here and a downtick and the different shape of the uptick and downtick. And it's just an eye chart for the operators. We've actually been called in after graphics like this were deployed, and the operators just absolutely hated them, and we've gotten called to come in and do some cleanup work. try to make this better. What can we do to make this better? Because now look at this wonderful contrast of this trend line that you're expecting the operator to look at. Can you see that? And again, I have not doctored these. I did not doctor the contrast to make it so poor. Now, do the alarms stand out? This is an alarm, cyan on gray. Not much contrast, and certainly not with a good boundary around it. I'll show you another example of that. Now, you might say, well, we have a standard. It's called ISAE 101. Surely we have some good examples in there. No, we don't, and don't call me Shirley. This is an example of in ISAE 101. They were intentionally, frankly, kept not so good. But this is not worthy of being called a level 1 graphic. It's unrealistic. The point is you can't look to ISAE 101 standard for examples of good graphics. They are not in there. This is a current one that's in a draft. We're writing a few, I'm on the committee, by the way. We're writing a few technical reports to supplement the standard. You can't put a lot of detail in a standard. So we're writing technical reports. And this is a draft technical report, and somebody wanted to submit this as an example. All right, so again, gray on gray blob. Here's a really interesting thing. So here's a tank. We're going to physically depict the tank. Nothing wrong with that. Where is the level in the tank? It's this horizontal indicator. Cognitive dissonance. Why would you put a horizontal indicator for level in a tank? It's just dumb. And actually the mixing of horizontal and vertical analog indicators is in general not recommended. So here we've got process values. They're using the same color and contrast for the process values as they are for the plain old text on the screen. That shouldn't be done. Those should be differentiated. You should always be able to recognize a live process value compared to just a label on the screen. So it's another poor practice. Poor layout, no trends, poor contrast. The ASM Consortium has a book out there. I advise you to get it. The text principles in it are pretty good. We're not big fans of the graphics, however. Their paradigm is a colorless gray-on-gray P&ID view of the process with a very few tiny analog indicators scattered around it. We think we think that you can do better than that. This is an example of something they're calling an overview display from a design guide. I would say this is situation awareness, okay, even if you were seeing the numbers. Again, this very poorly constructed, lots of crossing lines for no good reason, gray on gray, at least they have outlines around the vessels, but here with scattered, tiny, unbounded analog indicators. Believe it or not, there are, how many alarms, raise your hand really quick, how many alarms are in effect on this screen? Quick, quick, quick. A lot of people, well, are you looking up here? This is like a summary for everything you're looking at. What I mean is this. Does that stand out as an alarm? Not a lot. It does have this little tiny alarm indicator that is bounded, but this yellow on gray is not. And over here, look at this one. You barely see this one at all, the cyan on gray, even the cyan on gray symbol. The cyan is not bright. The symbol is too small. No trends, no poor alarm depiction, poor layout, crossing lines, very tiny analog indicators up here that are not that helpful. I would say this is not worthy of being called a good overview graphic. This is from a different design guide. This is a level 2. Again, here you have some analog indicators here, but they are so dim, so indistinct that you can't make them out. These little you can't even make out these tick marks, but they're important. I mean, you're supposed to be able to read that and differentiate your understanding based on the proximity of certain things to those. So, no, you're getting the idea, right? Low contrast, you can't tell the live values from the raw text. Again, that's a well-known principle. This 50 is not raw text, it's a live value, but it looks exactly using the same things as some of the labeling. called a level 3. I would say this is also a poor level 3, but level 3, like I said, is kind of where your PNID view lives, but this is not even that great of a PNID depiction. So low visibility and low contrast is poor design. So now, this one is up at pretty much full screen size. So this is another example. I want to talk about a particular thing. Again, this little tick mark that goes down for 3 pixels, those 3 pixels are very important. So naturally, we make them almost impossible to see. Whether or not it's a tick mark or a little flag kind of thing is really, really important, and that's at least a 3 pixel difference. So, but the other thing about, and you can't see the trend lines very well, but the other thing about this is, look how small those elements are. And look how much white space there is on this screen. Do you think it might be a little better if the elements that you're looking at were larger and you had less white space? Well, the AMUA 201 document had in it this little throwaway line that 30 to 50% of your graphic should be white space. Well, that's dumb, all right? Why is that dumb? Okay, there's nonsense in there about display packing density and this kind of thing, but here's the control panel, instrument panel of an aircraft. Any other pilots in here? Well, I would ask you, anyway, you go on an airliner, you look to your left, there's the cockpit. Would this pilot be better off if all of these instruments were smaller so there could be more white space on this panel? Would you say, that's a great idea. I really want my pilot to be shooting an approach through a rainstorm down to minimums with fog. I really want his instruments to be smaller. Okay? No, you wouldn't say that because y'all are all smart. Okay? So your screen space is highly valuable. The space on that screen is highly valuable. Use all of it. Use it effectively. Do effective layout, and don't worry about the white space. That's just dumb. So here you see, here's a row of our example indicators. Okay, you notice how legible they are, clear boundaries, the alarms stand out, and so forth. Well, if some of the people that I'm showing you their work for, if they did this graphic, it would look like this. Is that better? Do any of you think that that is better? Is that easier to see? The proximity of your reading versus the various possible conditions of normality, of alarm, of anything else. I would say no. I would say this is a bad idea. This is poor contrast. You should not do this. And as a customer, you should not accept this. So don't be fooled. The enemy of good HMI is camouflage. And we're seeing way, way too much of it, okay? If you're interested in more principles about high performance HMI, I would say obviously get the book. Now we wrote instead of doing a second edition, the book did not have that many examples in it. A lot of it was brand new concepts. But just a couple of years ago, we wrote a major 2-part white paper. Over 70 examples, color examples in it, new depictions, new examples, case studies, actual case studies from people that have implemented high performance HMI, proof of the concepts, all that stuff. It's absolutely free. You can email me to get a copy of it, or you can go to our website and download it, 2 parts. If you take that white paper and the book, which has all the work process stuff in it, you have the most complete, we believe, source of information about how to design an effective process control HMI that's in existence, okay? So we encourage you to, and just the white paper by themselves, the 2 white papers by themselves are a good introduction into the concepts. We do cover a few of the basics, all right? So that is end of Rant, right? That camouflage is not good. Don't accept graphics that are examples of camouflage. Questions? Stan, you're first. Stan in the back right there. Dr. Stan Zisman, y'all.
I try to keep that secret, but that's, yeah, it's
Now
out
it's
of the
out.
bag now. So a couple questions.
Yes, sir.
on your ideal graphics, when you have, let's say you have multiple alarms going off at the same time, that little side graphic, do you have to select each individual alarm and then it will put up the information that operator needs to react?
If there, the short answer is yes. For this, if the operator will be very familiar, the experienced operator will be very familiar with many of their alarms. The newer operators may not. And even an experienced operator has not received every alarm.
Yeah.
So it's making the information accessible. Now, there's a variety of ways you can do that. You can create a separate call-up screen of the master alarm database where they access it in some way. We just say embedded in the HMI, so if I get this pressure alarm, here's what it's about. Causes, corrective actions,
another
etc.
alarm on that page, you just select the other one.
Here the agitator has a priority for a diagnostic on it, so I could select that and see what that was about. Although, see, the agitator, this is an example of level 2. The agitator is a sub-assembly that works really well, so I don't put a whole lot of detail about it on the level 2. I would go to the level 3 M5 agitator, and I would see all the details about that if I need to. So
Okay, if I'm just missing this because I don't see it, this is my second question.
Yeah.
So if by chance you're hitting a safe operating limit, do you color code and show a different icon for that?
If and I'll send you the white paper, but you notice some of these have black spots at the top or the bottom or both or neither?
Right.
That's an indication and a reminder to the operator that this particular measurement is an input to some sort of interlock function.
Right.
So we expose that on the screen. For this pressure, the operator knows, oh yeah, that's interlock. That interlock, I remember now about that interlock. If I let that pressure get too high, it's going to activate. All right? So we're visually reminding them of that. In their training, they're supposed to know that, but my memory isn't getting any better. All right? So we visually expose that. In that case, there might be a pre-alarm or not. Other questions? You were fast with the, okay, you handle it. Other questions?
Curtis Vila with Dino Bell. I've talked to some other folks, and there's some noise around a slightly blue hue on the background is a way to go. Have you heard anything confirming from your point of view? If
There's a certain company that's really in love with blue, and they got it in their advertisements. The problem, the reason that you pick the right gray is that it's color neutral, and you do not have color combination issues with the rest of your palette. Slight blue tinge, big deal. Some people, for example, they like the, where I show a light blue for normal, they like a green. Because a lot of people associate green with normal. If so, don't make it that bright, fully saturated green. Make it the pastel green of about as pastel as that blue is, and that's okay. There's some personal preference things. We like this. We've had good feedback on this, but I would not say go to a blue background. Black is long gone. It's one of the worst ideas, and it was a consequence of the physical limitations of cathode ray tube monitors at the time, and they're low frequency. And I'll get my white paper, and we can have a separate conversation. But you never want a black background anymore. It's the worst possible combination for causing glare and reflection. It's why we turn down the lights in the control room. The control room should be bright 24/7. Todd.
In terms of transition between PNID graphic displays and high-performance displays, I grew up with really old-fashioned DCS where all you had was markers, basically. Bars and numbers.
Yeah, TDC 2000?
Yeah, exactly.
Yes.
Exactly. And my personal view is we've regressed over my 37 years, to the point now that people don't even know what they're looking at. I'm just wondering now the transition to go from PNID-based graphics to high-performance graphics. How do you make that happen? I mean, what's your experience of making it happen?
It's a great question, and we have a separate presentation about that called Overcoming the Objections. And what basically is this: if all you have are PNIDs covered in numbers, what you have are rather poor level 3 graphics. hey, you need level 3 graphics, okay? They could be better, but you've got to have level 3s, all right? So fine, accept that they're level 3s. What you probably don't have is a level 1, maybe a level 1 abnormal situation graphic, and you don't have level 2s. So you can add those. One of the things we say, don't say to your operators, we're going to get rid of your graphics and give you all new ones. Don't do that. Keep everything you have, add some properly designed level 1 and level 2s, and they will start using them because they're better. And we have case studies to prove this, okay? Over time, you can make your level 3s better, but you don't have to throw everything away. You don't even really have to revise it. And don't give me this stuff, oh, my operators will be horribly confused. Well, your operators have a PC and an iPad. They can go from one, don't be patronizing to your operators.
What I'm looking at right now is getting level 1 screens.
Uh-huh. Actually, I find it's easier to develop your level 2s first, and then your level 1 is an abstraction of those. You think I always start at level 1, but actually you design your level 2s the right way, and it's not by picking what's on a P&ID. It's through task analysis, and it's not as complicated as it sounds, but all that's in the book. Okay, I'm over. I will be
We'll do one more.
more.
And then if you've got anything else, we'll hit you up afterwards.
This one, Engineer Energy.
So on your level 1 and level 2, I can't quite see that far, but it looks like you've kind of gone away from tag numbers on there.
Yes, I'll never show a tag number.
When you're, if when you have a separate process control and safety transmitters, what you said about the black on the interlock, are you only showing on these level 1 and level 2 your process control analog value?
I am showing the value that the operator uses to control the process. I am not showing all the details of the redundant voting systems and things like that on my level 2, because the whole purpose of this level 2 is for the operator to spot that something's heading there and to avoid it. Everything the operator needs to do 90% of the things they could possibly do with this reactor are designed to be on one level 2, so there's not a lot of this navigation. If they get into that, they go to a level 3 that has the details of all the interlocks, and it would show the redundant transmitters and their conditions and all that stuff.
So that would be the two transmitters next to each other would be on the level 3 with where you can see the deviation if there was.
Yes, yes, if there was.
All right. Thank you, Bill.
You're welcome.